Good evening, everyone. Today's session is on algorithm, that is bag of words, and it is coming under the topic one of the domain of artificial intelligence, that is natural language processes. So we will be covering the basic concepts and how this algorithm works on different tokens and what are the different processes that are basically involved in implementing this algorithm, right? So let us begin with the session. First of all, we need to understand what are the different steps that needs to be taken for this algorithm, right? Before this algorithm, so we have the data pre-processing kind of thing. So this is the first step. When you process the data, basically in this step you need to we will be talking about the very important thing, that is text normalization, right? So basically text normalization helps in cleaning up the textual data. Like suppose you have number of you have one sentence and there are number of words within that sentence. Now which word is basically having the highest weightage? How to remove the stop words like he, she, it from a statement, right? So this is how we basically normalize that particular text and come to a level where we have only the actual keywords on which this particular sentence is uh, becomes the meaningful sentence, right? So let us start with that. First step is text normalization. We undergo several steps to normalize the text. First, at to a lower level, first we are going to start with, like, you have sentence segmentation, then you take out the tokens, then you convert it into tokens, and then you remove the stop words, and then you check out like all the words are coming in a lowercase or not, right? The most important here in text normalization is what is a corpus, because most of the people get confused. What do you mean by corpus? So corpus is nothing. It is like when you have a text and it is coming from multiple documents, right? The term used for the whole textual data from all the documents all together is called corpus, right? So corpus, you might be thinking like it is a complete sentence which is containing the different words into it, right? So that makes a corpus. The first step when we have our text normalization, we have the sentence segmentation. So under this sentence segmentation, what is the process of sentence segmentation? We have a whole corpus, we have a whole sentence, we have a whole notebook here. Like we have a whole notebook, so it is called a corpus. It is called a corpus when you have multiple sentences and that are coming from multiple documents, right? And there are number of sentences in your single document, right? That document is referred to as corpus. Now what we have to do in the first step of this algorithm, text normalization, first of all, we segregate the sentences. We basically extract the sentences from those corpus. It is not like it is has the first priority, it is has the no, second priority. No, nothing like that. Line by line, one sentence is marked as one, second sentence is marked as second, third, and so on. So as many as number of sentences you have to just number them, and you basically makes the segments out of it. So here, like we have in CBT, we learn to decipher the lies where we are undermining ourselves with based on the bias embedded in the things we say. So this is the complete sentence, right? From here to here. So this is marked as one in the sentence segmentation, right? The second sentence, for example, I am never going to make any friends, is an example of all or nothing thinking, and we feel bad because we buy into this thought. So this would be your second sentence. For example, till thought, right? So this will be your second sentence in the sentence segmentation part, right? So this is how we basically divide the corpus into and convert that corpus into multiple sentences. We basically extract the sentences out of it, and we are not leaving or we are not prioritizing it. It is just making the sentence out of the corpus. The next step is tokenization. right? Now let us understand what is tokenization. We have taken the first sentence of our corpus, right? After segmenting the sentence, each sentence is further divided into tokens. So tokenization is the second step of sentence segmentation, right? Tokens is a term used for any word or number or special character occurring in a sentence. It could be anything, even if your comma, dash, they are also treated as tokens, right? Under tokenization, every word, number, special character is considered separately and each of them is now a separate token. You are not removing anything, right? We are not removing. Even our full stop has to be maintained as a token. So what we have done, we are converting the sentence into a token. Single sentence converting into tokens. Like you have in, so you have taken in first token. Second CBT, second token. Comma, third. Yes, third would be your comma. Then we, you take out all the words. We learn to decipher the lies. We are, and even your dash part will be taken as a token, right? And at the last we have the full stop also, never to forget any of the symbol, right? So this is tokens. This is how we generate tokens out of sentences, right? Once you have basically your corpus is converted into sentence, and then you apply the tokenization process in which you basically separate all the things, right? Then next step is removing the stop words, special characters, right? What do you mean by stop words or special characters? All of us knows special characters and special numbers. Stop words are frequently used words like is, mr, he, she, it. So all these are treated as stop words, right? Let us understand. Stop words are the words which occur very frequently in the corpus but do not add any value to it, right? Humans use grammar to make their sentences meaningful for the other person to understand. But basically, we are converting these things into we are basically making the machines to understand and get summary out of this, or generate the different answers, right? But grammatical words do not add any essence to the information which is to be transmitted through the statement, hence they come under stop words. Some of the examples of stop words are like is, mr, you might be having the second next thing, uh and they all are stop words. So our next step is to remove the stop words, special characters and numbers, right? So what we have done, first part may we have taken the sentence segmentation, second step may we have taken down the tokenization process. In the third step, now you are checking each of the tokens and removing the stop words, right? So these words occur the most in a given corpus. Basically, in every sentence, we have such words, but talk very little or nothing about the context or meaning of it. Hence, to make it easier for the computer to focus on meaningful terms. That's what I am saying. The key words that are used in a sentence, these words are removed. They are not the keywords, right? They are not forming. They are just giving a grammatical body to the language, right? Along with these words, a lot of times our corpus might have special characters or numbers also. Now it depends on the type of corpus that we are working on, whether we should keep them in or not. Like suppose sometimes we have some special characters, like you cannot remove at the rate from the email IDs, right? Because it is the special character that is very much required. You cannot do so, right? So let us take an example how to do so. You are not going to extract the email IDs at the rate from the corpus. This is the main point. If you are working on a document containing email IDs, then you might not want to remove the special characters. You might not. And the numbers, whereas, like suppose my email ID is something ABC123. If I am going to remove 1 2 3, anyone is able to understand my email ID? No. So you can't do so, right? Or in case you have your pen number, can you remove the numbers out of it? No, right? So there are some restrictions, there are some exceptions. Special characters and numbers, whereas in some other textual data, if these characters do not make sense, then you can remove them along with the stop words. Only if you have these kinds of words, right? Only if you have these kinds of words, like here, what we have, what we are checking it out, right? Like this. But if we have numbers or if we have special characters like at the rate, they needs to be taken into consideration whether it adds value to the sentence or the word or not. If it is value to the sentence, it is not going to be removed, right? It is not going to be removed. And if it does not make any value or they are just meaningless, so you can just remove them. That's not a issue, right? And then we are, the next step is to convert all the text into a common case. What do you mean by common case? Lowercase, right? After stopwords removal, we convert the whole text into similar case, preferably lowercase. So we usually use lowercase for converting the text. This ensures that the case sensitivity of the machine does not consider same words as different just because of different cases. So because we have the same spelling, we have the same meaning, everything is same, but only because of their different cases, might be using uppercase, might be using lowercase, might be using title case, might be using some other case, right? So all of these words will be converted into what? Will be converted into a lowercase, that is hello. So you might be using some capital letter, you might be using some in between capital letters, some O's like this, but all of these text are converted into a lowercase, right? So here in this example, the all 6 forms of hello would be converted to a lowercase and hence would be treated as the same word by the machine. So it is not going to be changed. You have to make understand the machine like these. If these words are coming, they are converted into the lowercase and they have the same meaning also, right? They don't have the different meaning. After this, we have already covered with the session, that is stemming and lemmatization. We have already seen the process of stemming and lemmatization. I'm just giving, you can refer to my previous sessions. Uh, the only thing is here I'm going to give an example to summarize both of them and tell you the difference between both of them. What is stemming and what is lemmatization. So when we apply a lemmatization process to any word, it comes basically, it removes the affixes and it is giving a meaningful word. What will be the derived word of this caring, right? We are not only talking about the removal of affixes part. In lemmatization, it is going to be, it, yes, it is a time consuming process, right? But it's give you an accurate result because it is extracting the words from the dictionary from where this word is derived. For example, let me give you an example. If you are using better, using stemming, might be using stemming, it is the stemmed word would be your bet, right? Whereas using lemmatization, the same better word would be your good, because the better word is derived from the word that is good. We are not removing any affixes in this case when we are using lemmatization process. So this is the basic difference. We remove the affixes part using stemming process. Yes, it is a faster method. It gives you the output so fast, but that output is how much accurate? The word is bet. Is it a meaningful word? No. So the output of the stemmed word is not meaningful. Whereas in lemmatization, the output word is the lemma is the meaningful word. So these are the differences between stemming and lemmatization, right? So in the next in the next step, like when we are applying stemming or lemmatization, it comes to the simplest form, but the same thing would be like the derived form will be taken out from the tokens, right? Let us see. With this, we have normalized our text to tokens, which are simplest form of words present in the corpus. Now is it time to convert the tokens into numbers. For this, we use the bag of words algorithm. Now, these are the pre-processings which needs to be done before applying the bag of words algorithm. Right? So now you have converted the words into tokens. Bag of words is what? You have a bag, yeah, containing all the words. Now you have all the tokens. Now what you have done is you have written down here that it is the occurrence of it in the particular bag is 6, I is 5. You assign, you basically here you are going to write, here you are going to write the frequency of each token in the bag. So bag of words is a natural language processing model which helps in extracting features out of the text, which can be helpful in machine learning algorithms. In bag of words, we get the occurrences of each word and construct a vocabulary for the corpus. So what we are doing, we are extracting the words and the occurrences of those words, the frequency of that word, right? So this image gives us a brief overview of how bag of words works. Let us assume that the text on the left hand side in this image is a normalized corpus. So you have the corpus like this, right? Which we have got after going through all the steps of text processing. So whatever we have done earlier. Now, as we put this text into the bag of words algorithm, the algorithm returns us to the unique words out of the corpus and their occurrences in it. So it might be possible like it has come 6 times. It is not going to write like it 6 times. No, it and the frequency, right? As you see at the right, it shows us a list of words appearing in the corpus and numbers corresponding to it shows how many times the word has occurred in the text body. Now what you are going to do is, like suppose you have taken out all the tokens out of your uh, text normalization process, right? And you put those words into a bag of words. In this bag of words you have number of words that may be repetitive, like it is coming 6 times, I is coming 5 times, the is coming 4 times. Now what you have to do, this algorithm just gives you that unique words and gives the frequency the occurrences of these words in the in some sequence, right? It is not any priority or like this. It may pick any of the word and then shows the frequency. Let us see what are the two things that are considered in this. So a vocabulary of words for the corpus, you will get what you get out of your bag of words. The frequency of these words, number of times it has occurred in the whole corpus. So here calling the algorithm bag of words symbolizes that the sequence of sentences or tokens does not matter in this case, as all we need is the unique words and the frequency. What it is meant by this statement, all these words are unique words and the corresponding frequencies which are there in the bag of words. So these are the two important points which we get. Now let us see what are the steps how to implement the bag of words. The first is text normalization. We have seen collect the data, reprocess it. Create a dictionary, make a list of all the unique words and the occurring in the corpus, like what we have done, vocabulary. Create a document vector. For each document in the corpus, find out how many times the word from the unique list of words have occurred. I will be taking an example. Let us see. Create the document vectors of all the documents, right? So what we have done, there are three documents. Document 1, where we have the sentence Aman and Anil are stressed. In the second document, Aman went to a therapist. In the third document, Anil went to download a health chatbot. So these are the three documents in the corpus, right? Here are the three documents having one sentence each. And in every document we have only single sentence. After text normalization, the text become, you will convert it into a token, and that are of unique, like Aman and Anil are stressed. Aman went and all are to a lowercase, right? None of them are following any title case for, or you may say like it's a name. No, nothing like this, right? And then in the third document again, we have converted into a tokens, right? Then note that no tokens have been removed in the stopwords removal step. It is because we have very little data, and since the frequency of all the words is almost the same, no word can be said to have lesser value than the other, because it is going to destroy the meaning of the word. If you remove any of them, like to and went, so you are not going to remove it because the document is containing only a single sentence, so there is no need. That's what I told you. Whenever you remove any stop words, like from an email ID, remove the special character, special symbol, or the number. It does not make sense later on, and it is going to disturb the information. Here also we have a single document here in which we have a single sentence, so there is no need to destroy it. Next, create a dictionary. Now what in dictionary, you are just take down all the words, but only once. No repetitive terms, unique words. So here you have seen, are you able to see this? The two, this two, this two, and this A are coming twice, but here in the list of dictionary, when we create dictionary, we have created at once, because later on we will checking it out in the document vector, right? So go through all the steps and create a dictionary. List down all the words which occur in all the three documents, but uniquely. Note that even though some words are repeated, it may be possible some words are repeated in different documents, they all are written just once. As while creating the dictionary, we create the list of unique words only. So what we are doing, we are just creating a dictionary but of unique words, right? Now let us take the document vector part. Next step is create a document vector. After creating dictionary, the next step is to create a document vector. In this step, the vocabulary is written in the top row, right? So here you have written down all the words that are extracted from here. Aman and are stressed, to went to a therapist, download health chatbot, nothing else. Now what you have to do is, I will tell you. Now for each word in the document, if it matches with the vocabulary, put a 1 under it. If the same word appears again, increment the previous value 1 to make it 2. And if the same word does not occur in that document, put 0. So basically this is Anil and Aman are stressed. In the first document, the sentence was Anil and Aman are stressed. So what we are going, here we are just taking the document 1. Aman and Anil are stressed. Rest all become 0 because this is the document vector and this is the document vector for document 1, right? Then, so we have repeated all these steps for document. This is document 1, this frequency. This is document 2, right? And this is document 3. Okay, so these are the 3 documents we have maintained. The document 1, document 2, we are creating the document vectors. So what we have done in the first document, what we have seen, Aman and Anil are stressed. In second document, Aman went to a therapist. Let us check it out also. Aman went to a therapist. Anil went to download a health chatbot. Let us see. Anil went to a therapist, went to a download, went to download a health chatbot. Right? So this is how what we have done. We have created the document vector. So this is like how we apply it and how we have zeros and ones in our document vector. So I am going to explain this part. In this table, the header row contains the vocabulary of the corpus, the same words, the unique words which are identified here itself in the second step. Whatever we have created in our dictionary, that is, we are going to use in this table only. We are not repeating the same things. We are not repeating the tokens, right? So, vocabulary of the corpus and 3 rows correspond to 3 different documents. Take a look at this table and analyze the position 0 and 1 in it. So, how it is created, I have shown you. The first document says about first sentence, Aman and Anil are stressed. In the second document, we are talking about, so this is how we create the document vectors, right? So, like we have the last step, that is how to create the TFIDs, that I am going to share in the next session, how we create the logs to this TFIDs. And then we check out whether this particular word has the weightage in the complete sentence or not, whether it is adding some value or not. So it is basically we are creating the term frequency IDs, right? So here finally this gives us the document vector table. This is the very important table. How to create it? This is very easy. I have just shown you. And then but the tokens have still not converted to numbers, right? This leads to the final step of our algorithm, that is generating the TFIDs, right? So I have shown this particular part, how bag of works algorithm works and how it converts into token, how it creates the dictionary, and then after dictionary how it basically creates the document vector. Now the last step I will be telling you in the next session of how to generate TFIDs using this example only. So I will be taking these steps, right? And then I will be moving towards how to apply TFIDs function to it, right? So hope you have understood the bag of words. In this we have taken, first of all, data pre-processing we have done. Then after text normalization, we have created a dictionary, and after dictionary, we have a document vector. That document vector is containing all the document frequencies, and from this table, you can directly extract your sentence also, right? You can directly extract your sentence as well, right? And then we write down the frequency. If that particular word is present in that particular sentence, then we put 1. If it is not present, then we put 0. This is how we put 0 and 1 values into the document vector. Once your document vector table is ready, then you apply the another algorithm, that is TFIDs, right? So we will be talking about TFIDs in the next session, and I will be explaining you with the same example, continuing with this session only, right? So hope you have liked this session. Hope you understand the concept of text normalization, how to create dictionaries, how to create document vectors, what are stopwords, when to remove stopwords, when to use stopwords, right? What are stopwords? So everything is, I hope you have understood, and every concept is clear, right? So hope you like this session. Thank you.